Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Allahumma arhamna. As-salatu was-salamu alayka ya sayyidi ya rahmatan lil alamin. Amin bijahi khatamin nabiyyin. Sallallahu alayhi wa alihi wa sallam. Alhamdulillahi rabbil alamin. S1 exam last minute revision tips. In this video, I will cover some important concepts, formulas and exam tips for the S1 CAIE exam. These last minute revision strategies will help you improve your preparation, avoid common mistakes and boost your confidence before the exam. Let's begin. Make sure you remember all the formulas that are not given in the MF19 formula booklet, especially mean and standard deviation using assume mean method. These two formulas are very important. They are not given in MF19. And remember, we substitute this result here, not the result of mean. Number 2, combined mean and combined standard deviation. We have two formulas for combined mean and one formula for combined standard deviation. And we find sigma x1 square with the help of this formula. Sigma x square n1 x1 bar square. So by making sigma x1 square subject from this formula, we can easily get sigma x1 square. Similarly, we can get sigma x2 square as well. Now the next thing is, for ungrouped data, quartile formulas and median formula. Median formula is same for both even and odd observations. It's n plus 1 upon 2th observation. Whereas quartiles formulas are different. For odd observations, the Q1 formula is 1 upon 4 n plus 1th observation. Whereas Q3 is 3/4 n plus 1th observation. But for even observations, this is very important. The formula is n upon 4 plus 0.5th observation. And for Q3, 3n upon 4 plus 0.5th observation. Make sure you must remember these formulas. The next thing is box plot. Let me find a question. This is here. Well, for box plot, make sure you know how to draw them properly. Always label this horizontal axis. Take a proper scale and write whatever given over here. The data is length in meters. So write this here. And since 10 power minus 3 is common, then take the proper scale. And you must know how to compare the box plots. So when comparing two box plots, always compare their medians and their ranges. While comparing medians, always write on average. For example, here, on average, machine A, this is machine A, its median is greater than median of B. Machine A produced longer rods than machine B, but you have to mention on average because you are comparing their medians, right? The second comparison is based on their ranges. So this has longer range, box B, so you have to say more variation in machine B's rods than in machine A's rods because of its greater range. Now for stem and leaf diagram, always include a key. Let me find a question. You have to mention the key. This is here. See, this is the back-to-back stem and leaf diagram. So make sure you must mention the key. So 362, this is here. So this means 36 centimeter in D, whereas this means 32 centimeter in L. So make sure you must write key properly. And you must know how to find median and quartiles from stem plot. Since we have odd number of observations, therefore for median you can use this formula for both even and odd number of observation. There are 11th observation, so 11 plus 1 divided by 2, 12th. 6th observation. Median is the 6th observation. So this is for D. So 1, 2, 3, 4, 5, 6. This is the 6th observation. Now read this as 15 centimeter. For Q1, I told you the formula, it's 1 upon 4 n plus 1th observation. So 11 upon 4 and plus 1. So it's 3rd observation. Then Q3 is 9th observation, IQR is Q3 minus Q1. What if they ask write semi-interquartile range? So divide IQR by 2. That's the semi-interquartile range. Now here we compared medians. The median, lower quartile and upper quartile of the weekly snowfall for L are this and this. Use this information and use your answer to part B to compare the central tendency. So central tendency means median for box plot and stem plot. Always compare median for both. And spread, compare their ranges or IQR. Since IQR is given, so compare their IQR. So median of D is greater than median of L. So you have to write on average more snowfall in D than in L. Now compare their IQR. IQR of D is less than IQR of L. So snowfall varies more in L than in D. Right? Snowfall varies more in L because it has greater IQR than in D. This is the way to compare stem plot. Data in stem plot. In box plot, we compare ranges instead of IQR. We just did that. Now for frequency distribution, be confident with mean and variance calculations. What if they ask find mean and variance? Let me find a question. Mean and variance like this. Here histogram is, this data, continuous data is given and we have to find mean and then standard deviation. In fact, mean is given, in fact standard deviation is required. So this is the formula of standard deviation. Sigma under root sigma fx square. This formula is given in MF19 and mean square. So fx square means sum of the product of fx square. So this is very simple. You must have x. X means mid value. So get the mid values of this, these intervals. So the mid value of this is 10, 25 and so on. So x is here. Now take, like this. Take the product in this way, fx square. So f is 440, then 10 square plus 720, 25 square, 920, 35 square and so on. This is here. F x square and subtract square of mean. This is the way we calculate mean, standard deviation from frequency distribution. Let me find another question of the calculation of mean and standard deviation. This one. Here we calculated both. We estimated mean and standard deviation. So the formula of mean is sigma fx over sigma f. This formula is available in MF19. Now get the mid value. Take the average of these two numbers. So 1 plus 10 divided by 2 will give you 5.5. This is here, mid value. Then take the average of these two and so on. Now for mean, 18 times 5.5 plus 24 times 13 plus 30 times 23 and so on. This is here. Now for standard deviation, copy this entire thing here. And then just square this x. Just x values, square the x values. Divided by total and minus the square of mean. Since this answer is exact, so leave it as it is. Don't write this answer as 23.6. It would be incorrect. Because Cambridge says give non-exact answers up to 3SF. Since this answer is exact, so leave it as it is and use this answer here. This is up to 3SF. So this is the way we find mean and standard deviation from frequency distribution. Now you know how to calculate frequency densities for histogram. It's very simple. If you find class width from here, then make sure you take both inclusive. I mean 10 minus 1 is 9 plus 1, because 1 and 10 both are inclusive. So it's better to find class width from class boundaries. 10.5 minus 0.5 will give you 10. So this is the class width. Now frequency density is frequency upon class width. So frequency divided by class width 10. Frequency is 24 for this class and the width is 5. So 24 divided by 5 will give you 4.8 and so on. And draw the histogram clearly. And you must understand the shape of the distribution. Since highest bar at the beginning, so this data is positively skewed. Like this, a long stretch tail on right side. So this is positively skewed. In box plot, its shape is like this. Quartile is Q1 is close to, median is close to Q1 in fact. See, this is positively skewed in box plot. If median is close to Q1, then it is said to be positively skewed. If median is close to Q3, then it is said to be negatively skewed. If median is slightly shifted from the center, like here, not exactly at the center, this is known as approximately symmetrical. And if median is exactly at center, then it is known as symmetrical. And you have to label the axis, write frequency density. Don't write FD, don't use short terms. Always write the complete things or complete statements. Take the scale very properly or very carefully. In cumulative frequency, always go for cumulative frequency curve. I drew a polygon, but it's better to draw a curve. Okay? Don't go for polygon. Draw a curve. I'm drawing a curve because they prefer curve. Alright? Now according to curve, the estimate is here. So this is, I guess, 43. This is with respect to curve. Now this part is very important. 24% of students take K minutes or longer. So whenever it says more than, at least, or minimum, for all these terms, always take the upper part of the graph. So 24%, change it, 76% of 150, this is 114, so you have to go from here, okay, this is 114. Now check the corresponding value of this. But if you are going straight away, 24% of 150, that should be, I guess, 36. Now check from here, 36. So you have two options. If you are going through direct method, like you are taking 24% of 150, you will get 36 observation. So take it from here. 150 minus 36 is 114. Okay. Or if you are using indirect method, 100 minus 24, then you can check from here. So you have both the options. Now this is very important. You must know how to draw frequency distribution from cumulative frequency distribution. If data is continuous, then you have to go for class boundaries, right? So just copy this here, and the first value of lower class, the lower limit of first class must be 0. Please remember, for continuous data, this must be 0. I explained this for discrete data. Now this 20 is inclusive here, so it must be exclusive here. You must be very careful regarding these signs. Now complete this. How to get frequencies? 150 minus 134 will give you 16. This is the frequency for this interval. And 134 minus 106 will give you 28. This is for this interval, and so on. Now after getting class boundaries, get the mid values. Take the average of these class boundaries. Now after getting x and f, use the formula of mean, it's sigma fx over sigma f, and get the correct answer. For variance, this is so simple. Copy this statement here and just square x values. Divide by total and minus square of mean. This will give you standard deviation. Now let me check if we have discrete data here. I don't think so. There is a question in this worksheet. Let me find this from the notes. S1 notes, representation of data. I explain the conversion from CF to frequency distribution from these nodes. So this is an important question, an important concept as well. The conversion. Alright, let me find another nodes. It should be over here in this. Yes, I got it. Now this is very important. Alright, now try to understand this concept very carefully. I told you for continuous data, no problem whether we have exclusive value or inclusive value, the first value must be 0. Okay, this is copied here. Since this is exclusive, so this is inclusive. This must be 0 for continuous data. If we have this like this, no problem, copy this here. Since this is exclusive, so this is inclusive. So for continuous data, the first value, the lower limit of first class must be 0. Now for discrete data, the rule is different. For inclusive values, we copy this number here and this value must be 1. If this is inclusive, then this value will always be 1. And if this is exclusive, obviously you can't write 10 here, you have to write 9, and here must be 0. So in case of exclusive, the first value of lower limit must always be 0, and in case of inclusive, this value must be 1. Now let me show examples of these. See, this data is discrete. Why? Countable quantities, number of pupils, countable thing. Discrete means countable, continuous means measurable. See, this is inclusive. So how to write class intervals? These are class intervals. Now copy this 100 here and the first value must be 1, like 1 to 100. The next one is 150, then this is inclusive here, so write 101. Then 151 to next value 200. This is the way to make class intervals for frequency distributions. This data is discrete and this is inclusive. So first value must be 1. And this is the way to get frequencies. This minus this minus this, and so on. Now let me show you another question in which the values are exclusive. See, again we have discrete data. Marks are discrete, they are countable. So exclusive, so write 0 to 9, then 10 to 19, and so on. And why do we construct frequency distribution? We construct it for the calculation of mean and standard deviation. Now take the average of these two for mid values. Alright, this is done. Now the next thing is you should know when to use box method, when to use the spaces method, when to use counting method in permutations and combinations. PNC. We use permutations for the arrangements. Here we use combinations. For selections we use combinations, and for arrangements we use permutations. This is the basic difference between these two. In combinations, order of the selection is random, whereas in our permutations, order is specific and order is important. Arrangements are always orderly. They are orderly arrangements. In permutation combinations, read the questions very carefully and identify whether it requires combinations or permutations. Right? And you must know when to use box method, when to use the spaces method, and when to use counting method. This is the counting method. Now let me show you some examples. And you must know that in combinations, if it says find probability, then you have to show combinations even for the selections of identical objects. This concept is extremely important. If it asks for probability of selecting letters, then selections of repeated letters must be shown separately using combinations such as 3C1, 1O from 3 O's. This is we do when it says probability in selections. But what if the question is just selections, unique selections? Then you don't need to show combinations of identical objects. See, here we have to select at least 2 E's and at least 1 R, and these are the repeated letters. So for 3 E's, don't write anything here. For 2 R's, don't write anything here. See, for 3 E's, no, don't write. For R, don't write 2C1, because this question is only for selections. So if there are selections only, then you don't show selections of repeated letters separately. Understood? Just selections. So no need to show selections of repeated letters here. But in case of selections with probability, you have to show the selections of repeated letters as well. So make sure you understand this concept well. And you must know the meaning of the terms at least, at most. At least means greater equal, at most means lesser equal, exactly equal, and like this. Now the next thing is probability. And you must know these terms in permutation combinations are not altogether. For these types of questions, always use box method. First get total, then get with restriction, and then just subtract. This is the total, this is the restrictions, now this minus this. Okay, where do we use the spaces method? See, an arrangement of 8 letters in the word release is chosen at random. Find the probability that the letters A and D are not together. By the way, you can solve this question with box method as well, because exactly 2 letters. They are talking about 2 letters. But what if they are talking about 3 letters, A, D and S? Then never use box method. Always use the spaces method. I use the spaces method here. A and D are not together, so they are not together. And the remaining letters are 6, so first arrange remaining 6 letters. So 6 factorial, and there are 3 repeated letters, there are 3 E's, so 3 factorial, 6 factorial for remaining, and there are 3 E's, so 3 factorial. These are 7 slots, fill any 2 slots, 7p2. And divide by total because it says probability. Since this video is only for last minute tips, so I'm not discussing more things in permutations. I hope you have done permutations. I was just discussing some important points. Now here you must know the conditions for mutually exclusive events and independent events. In probability, independent events means this condition must be verified. For events are to be independent, this must be verified. For exclusive, these are 2 conditions. If it says state the conditions, then you have to write both. But if it says show that events are exclusive, then always verify this condition. This condition must be verified for exclusive events. And you must know the formula of conditional probability. We write given information here and their intersection here. These are probability rules. You must know these rules. Total probability is always 1. Probability A, plus probability except A is 1. Probability always lies between 0 and 1 inclusive. See, the total of each branch is always 1. If this is x, this must be 1 minus x. And there is a condition, it's given this probability does not sing 0.58. So this result and this result, if you add these two, this is 0.58, you will get x. Find the probability that both students play in the band and both sing in the choir. This is so simple. Just check the requirement. 0.6 into 0.3 band and choir, not band and choir. Alright, it says both students. So this and this both. So one student, another student. So 0.6 into 0.3, again 0.6 into 0.3. Both students play in the band and both sing in the choir. Band, choir, band, choir. In probability distribution, you must know how to draw the table, how to construct the table. And for that, you must know the meaning of x. Let me explain this from here. How to how to construct probability distribution. So this information helps you. They always define the variable. A bag contains 5 red balls and 3 blue balls. Sadi takes 3 balls at random from the bag without replacement. Well, for without replacement, you can use combinations. The random variable x represents the number of red balls. Now, you have to decide the values of x. Okay, first part, show that probability that Sadi takes exactly 1 red ball. This is so simple. 1 red ball out of 5, 2 out of 3. So this is the probability through combination method. Now how to decide the values of x? So let me explain this here. X means red balls. So available red balls are 5, blue are I think 3. Now we have to select 3 balls. So write 3 here and check the combination 5C3 is possible. So this is perfectly fine. So all red can be possible. So this should be 0. Now try to write 0 here and 3 here. So this is also possible, 3C3. So no red ball is possible. But what if this number is 2? Then this is not possible. That means this is not possible, so you must have at least 1 red ball with 2 blue balls. If 1 red, then there are 2 blue. So the minimum value of red is 1. So 1, 2, 3. But in this case, we have 3 blue balls. So we can have all 3 blue. So we can have no red. So x can take these values 0 to 3. So this is the way to take the values of x in probability distribution. Let me show another question of this. This question. See, here x represents the number of paper bag. Now decide the values of x. So paper bag are 6, hard bag are 2, 6, 2, and we have to select, she chooses 4. Now write 4 here and 0 here. So this is perfectly possible because we have 6 paper bag. Now write 0 here first and try to write 4 here, but 2C4 is not possible. So 0 and 4 is not possible. Now try with 1 and 3. Their sum must be 4. Even 2C3 is not possible. Now try with 2 and 2. So 2C2 is possible. So the minimum value of P is 2 and maximum is 4. So X can take these values 2, 3 or 4. And here is the table 2, 3, 4. And how to find probability? Use combinations. All 4 paper bags, 6C4 divided by 8C4. Like this. And how to find mean and variance? Very simple. For mean, let me show a question in which I found both mean and variance. Okay, in this question, we have this table, we have to calculate mean and variance. This is the formula of mean. You can find this in MF19. Right? So, just take the sum of the product of these numbers. Like for mean, write in this way. 2 upon 15 into 1. 6 upon 15 into 2. 7 upon 15 into 3 and so on. That's it. This is here. X times probability. And for Ex square, copy this entire here and just square X terms. Make sure you square the X values, not probability. Now for variance, use this formula. This is available in MF19. You must be used to with MF19. So this is here and this result is here. So this is variance and its square root is standard deviation. This is the way we calculate mean and variance. So this is all from probability distribution. Now the next topic is binomial and geometric. In binomial and geometric, you must differentiate the distributions with the help of their conditions. In binomial, there are only 2 outcomes and n number of fixed trials. Probability of success is constant and trials are independent. These are 4 conditions. 2 outcomes, fixed number of trials, independent trials, probability of success is constant. Whereas in geometric, there are only 2 outcomes. This is similar, common, but this one is different. In geometric, the trials can be infinite in number. This is the main difference between binomial and geometric. This is the way to describe binomial. If they say describe binomial, then write in this way. X is binomial, write the value of n. If let's suppose 20, p let's suppose 0.3. This is the way to write binomial with its parameters. N and p are parameters. And x can take these values 0 to n. You must know the shortcuts. x0 q power n, xn and p power n, at least 1 minus q power n to make the calculations fast. Condition for normal approximation to binomial, you have to show this np greater than 5, nq greater than 5. You have to show the comparison. What if np is 60? Write like this, greater than 5. nq suppose is 15. That is why we use normal approximation. Show the comparison. Do continuity correction very carefully. Use number line for that. You should watch my lecture final S1 revision to understand these things carefully. This is the formula of Z after continuity correction. NP, NPQ under root. Let me explain just one. X greater than 40. Write the first inclusive integer here. The first inclusive integer is 41. If we go on right side, take the lower bound, 40.5. On number line, if you go on right side, take the lower bound. If you go on left side, take the upper bound. Like here. See, first inclusive is 50. We are going here, so take the upper bound. In geometric, trials are independent, same as in binomial. Probability of success is constant, same. 2 possible outcomes, same. This one is different. The repeated trials can be infinite in numbers. You must remember these conditions. And this is the way to describe geometric. There is just one parameter p. This is the formula of geometric. And r starts from 1. In binomial, x starts from 0. These rules are extremely important for geometric distribution. Must remember these rules. You have to learn these rules by heart. Mean and variance, I think, given in MF19, and you must be very good at this type of question, the mixed question of both binomial and geometric. Let me find the question from the other worksheet. All right, geometric distribution. You can find that question in this lecture, S1 final revision. I'm unable to find the question. Okay, so check that lecture. Make sure you have watched that lecture, or if you haven't, you should watch that lecture, final S1 revision. All right, the next is normal distribution. So in normal distribution, you must know where to use phi and where to use 1 minus phi inverse. You must remember these things. So for small area, for large area, always use phi. This area is large, so use phi, and make sure you write your answer up to 3SF. Expected number n times this probability. And make sure you round the number correctly. This means, if you are getting 316.4 days, so days, 0.4 can't make 1 day. Let me check what is this. How many days? Now let me calculate this, because days are always rounded up. I don't have the calculator. Let me check in mobile phone. Wait a minute, please. Remember, days are always rounded up. So 365 times 0.8657. 0.8657. This is 315.9. So 316. What if we got 315.2? Again, you have to write 316, because 0.2 means a complete day. You have enter in the next day, so a complete day. So write, in this way, always round up. But what if this means number of people? Always round back, because you can't make 0.8 as a 1 person. So round back. All right, inverse normal. In inverse normal, you must know how to shade the region. So here you are going on left side because it's inverse normal, so we shade in the opposite direction of the inequality. For greater sign, we shade like this. So from upper tail, since this area is less than 0.5, so stop well before 0. This is positive. Now since this area is small, so write 1 minus phi, this unknown, upon 560 is equal to area. Then solve this. Bring this here, shift this on other side, find phi inverse, and then get the value of n. Now this is a very important question. It's normal to binomial. So in normal distribution, if you get n less than 30, like here 6, so use binomial distribution. It says find the probability that daily sales at this petrol station exceed 8,000 liters on fewer than 2 of 6 randomly chosen days. Fewer than 2, n is 6, exceed 8,000, check this probability here. Exceed 8,000 is 0.122. So get the probability from normal distribution. So P is this, and get this by using binomial distribution 0, 1. And make sure your answer up to 3SF. You must know how to solve these types of questions. Differs means plus minus. Differs from the mean weight by less than 4 grams. Write mu here, mu plus 4, mu minus 4, and this area. Less than means this area. So less than, within, they both means this area. And more than means this and this, both areas. So here you have to find this probability. X lies between 78 and 86. Another example of this type of question. And you must be very good at simultaneous equations, mean and standard deviation. Two conditions will be given and you have to find two simultaneous equations first and then mean and variance. I did this in detail in S1 final S1 revision lecture. Now let me show you another question of important terms. See, these are number of days, so round up. If number of people, round down. Now this one. How many rods in this sample would you expect to have length is within 0.5 centimeter of the mean? So this is so simple, mu plus minus 0.5 and this area is required. Within means this common area. Between. So mu plus 0.5, mu minus 0.5, right? You can either use mu term here or these values. It's your choice. And then solve it. See, these are rods. So you can't make one rod. 0.4 can't be one rod. So round back or round down. Now journal tips. Use pencil for sketches, box plots, histogram, diagrams, normal distribution curve. Draw smooth curves neatly. Avoid careless mistakes. If you get stuck on a question, leave it and move on, then return later. Keep your working neat and properly organized. Avoid unnecessary shortcuts. Maintain 3 significant figures working. Accuracy wherever required. I hope these tips help you a lot. Do share them with your friends as well and be a source of benefit to others. Do good by everyone. All the very best for your upcoming S1 exam. Allah Hafiz. Sallallahu Alaihi Wasallam. Alhamdulillah Rabbil Alameen.